Continuing on in 14.1, I know this is a long lesson, so thank you for bearing with me through these videos, but I thought it would be better to chunk them out rather than one gigantic video that I would lose your attention for. So last video we were talking about square roots, and now we're going to talk about cubed roots. So to cube a number, it means to take a number and multiply it by itself 3 times. So a cubed number is to multiply it by itself times 3 times, or multiply it by itself 3 times, where a number squared is to multiply it by itself 2 times. So a cubed root is the opposite of a number cubed, or cubing. So to find the factor that when multiply it by itself 3 times, we would be finding the cubed root. So every number has 1 cube root. So there are some slight differences here between what we learned about last video with square roots and cubed roots. So every number has 1 cubed root. So can we have a cube root of a negative number? Well, let's see. So just like before, we have that radical, except to show that we're finding the cubed root, we have that little 3 that I have written right here. So here, what I just wrote out, that the 3 out front says the cubed root of -8. Well, so what we're looking at here is what integer times itself 3 times is -8. And that is equal to -2. -2 is that integer. You see, when we take -2 times -2, that's +4. And that +4 times the third -2 results in -8. So you can have a cubed root of a negative number. And now a perfect cube is a number that can be written as an integer to the 3rd power. It is a number that has an integer cube root. So let's list out the first 6 perfect cubes. Well, the integer cube root 1, 1 times 1 times 1 is 1. So 1 is a perfect cube. Now let's go on to 2 as that integer cube root. 2 times 2 times 2 is 8. Again, 3 times 3 times 3 is 27. 4 times 4 times 4, 64. And we can keep going on. 5 times 5 times 5 is 125. And 6 times 6 times 6. 6 times 6 is 36, and 36 times 6 is 216. So these are the first 6 perfect cubes. I encourage you to add to my list, maybe go up to the first 10 perfect cubes. So the next on the list would be 7 times 7 times 7. So how do we generate more perfect cubes for you to add to my list? You just like before, you take any integer and take that number to the 3rd power. And again, the result is a perfect cube. So now we're going to get into solving equations where we have x squared and x cubed. So to solve an equation with x squared, we have to do the opposite of squaring, which, as we said before, is finding that square root. And we do this to both sides of the equation. Since there are two squares, you will have two answers. Oops, that was not a W, my bad. You'll have a positive root and a negative root. And then to do it when you have x cubed, or x to the third power, you'll need to do the opposite of squaring, or cubing actually is what this really should say. So the opposite, I'm going to cross off that because that's a typo on my part. You'll do the opposite of cubing, which is finding the cube root. And you'll do this to both sides of the equation. And so in the next video, we're going to do some examples of that. Here now, continuing on, we're going to talk about how we estimate irrational numbers. So the key word here is irrational. So recall back to that very first video where we're talking about what an irrational number is. So we know that an irrational number can be found by taking the square root of a non-perfect square. So do we understand what that means? So a non-perfect square, we know that 4 is a perfect square because 2 times 2 equals 4. 5, however, is a non-perfect square because there is no integer that we can take times itself to equal 5. So 5 is a non-perfect square. So to find an irrational number, we can just take the square root of 5, and that would be an irrational number. Except what we do is we don't actually find the exact, we just find the estimate because, again, it is an irrational number. So to estimate that irrational number, and we'll use the example of the square root of 7 without a calculator, we're going to do it by using what we know about the perfect squares that we just listed in the first video, or in the video that you watched just before this. Hold on, I gotta plug this in. My battery is going to die, and that would be terrible. All right, so to do this, we're going to, to do this for the square root of 7, the first thing we're gonna do is identify which two perfect squares the radicand, which is the number under the radical sign, so 7. So we're going to identify which two perfect squares 7 lies between. And that is also how we're going to identify we're going to also identify which number it is closer to. So to start, the square root of 7. Well, we know that 9 is a square root, or a perfect square, because we know that the square root of 9 is 3. So now, if we've got 3 on one side, right, the square root of 9, on the other side, we've got the square root of 4, because the square root of 4 is 2. So 4 and 9 are perfect squares, right? We've got 2 squared to get 4, and 3 squared to get 9. Well, when we look at that, we can see that 7 is closer to 9. So 4 is less than 7, but 7 is less than 9. So really what that means is that the square root of the radicand lies between the square root of those two perfect squares, 4 and 9, and it's closer to 9 So the square root of 7 is between the square root of 4 and the square root of 9. And as we said, it is much closer to 9. So now when we estimate this out, we say the square root of 4 is less than the square root of 7, which is less than the square root of 9. Now, don't be alarmed if this is still confusing to you. We will continue to work on this both in class, and you'll see in the next video that we continue to practice with this. So just rest easy that we will get this, okay? This is a lot of information to take in. Ultimately, you need to make sure that you have your notes completed so that as we're still working through this information, you have your notes to rely back on, to refer back to as you're working through these problems.